Let's discuss about pressure in a fluid. About pressure in a fluid, we can write that when an external force is applied on a fluid body, it develops an internally distributed pressure at all points of fluid body. This pressure is called fluid pressure. The best way to understand this fluid pressure is to take up an example of a liquid taken in a container. Say we are given with a container in which a liquid is taken, and say gravity is acting in downward direction. So due to gravity we can say the weight of this liquid body is acting in downward direction. So at every point you can say we consider a point X in this liquid. The whole fluid weight which is above the point X will be pushing the fluid below the point X in downward direction. So if we just consider about a particle, liquid particle at point X, we can say, if we just magnify the situation, you can see there's say a particle of the liquid which is surrounded by similar particles in this manner which are also in contact with it. And in this situation we can say all those particles which are above the point X, due to the weight of upper liquid, these will be pushing this particle in inward direction as there are contact surfaces. So a contact reaction is developed here. Or not only at this point X will be pushing the particles in a downward direction which are below X. So another contact force is developed here. So at every point we can say all those particles are pushing the point X in inward direction, and point X is reacting other particles in radially outward direction. So if we talk about the point X, we can say at every point it will be experiencing a compressive force from the other side of particles, like the particle which are on this side will push X in this direction, those particles which are here will push X in this direction, like this. So at every point similar to X, the points will feel a compressive force in inward direction. Here we can say that the resultant force on point X due to all these contact forces by the surrounding particles will be zero, but the point X will be experiencing an inward compressive pressure. This pressure we call fluid pressure. And due to continuous contact of fluid particle, the pressure is distributed throughout the volume of fluid body, like this particle X is pushing the particle which is below it as it is in contact with this particle. Another contact force will be developed here. Similar to that, every particle will be having a distributed pressure. This pressure we call fluid pressure. There are some important facts and important points about the analysis of fluid pressure we are going to discuss in the next section. Let's discuss some important points about fluid pressure in continuation, like we have just discussed. First point, we can simply write down that it acts at all points of fluid body. As we have discussed, it is distributed, because on the previous slide we have discussed at one point of fluid pressure is acting, it is due to the contact by the neighboring particles. So if it is in contact with the neighboring particles, those particles will be in contact with the other particles, due to which we can say the pressure is distributed throughout the fluid body or in its whole volume. So whenever fluid pressure acts, it acts at all points of the fluid body. Another point we can write, at one point in fluid body, it acts uniformly in all directions. The concept is to understand if at a point fluid pressure is acting, then from all of its neighboring particle it is being pushed away, or you can say the particle will be compressed inward. So pressure will act at every point in all directions, due to which if it is in contact with any other particle, it will also exert the force on that. Now, based on the third point, we can define, which is one of the most important thing, if fluid is in contact with any solid surface, fluid pressure will exert a force normal to that surface. This is quite obvious because we can simply state fluid pressure is due to the contact forces by the neighboring particles. So if there is a situation in a container, a liquid is filled, and say inside we consider a small cube, then if it is a solid cube, we can say those liquid particles which are in contact with the right edge of the cube will push the edge in inward direction. Those which are in contact with the left edge of the cube will push it in again inward direction. So we can say all those liquid particles which are in contact with the surfaces of the cube will have a tendency to push the cube inward, because all those liquid particles which are in contact will apply a normal force onto the surface of this cube because of fluid pressure. Now, in any situation, if we talk about the container walls, those liquid particles which are in contact with the container walls will push the container walls in outward direction, or you can simply state the force applied by the fluid particles on the container walls will be normal to the surface, because these particles are experiencing pressure in inward direction from all of its surrounding, of which the resultant on the wall surface will be in the direction normal to it. Similarly, at the bottom, this force will be in downward direction. On left side wall, it will be acting in left side direction. So we can directly keep in mind that if a fluid is in contact with any solid surface, fluid pressure will exert a force normal to that surface. Based on this concept, several numerical derivations we are going to execute. So just keep these important points always on your tips.